Welcome you all. In this session, we are going to discuss the short circuit MVA or the fault level. After successful completion of this session, the student would able to estimate the short circuit MVA or the fault level for the given power system. Short circuit MVA or the fault level. When a fault, very large current used to flow. In order to minimize the damage caused by short circuit, the fault session need to be disconnected. The circuit breakers are used to disconnect the faulty session. The rating of current breaker depends on the short circuit MVA, which is also known as the fault level or the fault MVA. The circuit breaker breaking capacity must be equal or larger than the short circuit MVA. Estimation of short circuit capacity is made on the basis that it must clear a three-phase fault with zero fault impedance, as it is generally the worst case. By simulating three-phase fault at a point, by using subtransient reactance of machine, short circuit level at any point can be computed. Short circuit MVA is equal to pre-fault voltage in per unit into fault current per unit into base MVA, unless it is given otherwise. Pre-fault voltage shall be taken as 1 per unit. For example, let us consider this system. The figure shows four identical alternators in parallel. Each machine is rated for 25 MVA, 11 kV, and has a subtransient reactance of 16% on its rating. Compute the short circuit MVA when a three-phase fault occurs at one of the outgoing feeders. Here you can see it has four alternators. See, in this given system it has 4 1 2 3 and 4 alternators, which is connected to a bus of 11 kilovolt. Solution: the fault is simulated by closing the space as shown in per unit reactance diagram. So this is the reactance diagram. All the generators are represented by its EMF and reactance as 0.16, all the four. So the equivalent circuit, Thevenin's equivalent circuit is taken as 1 per unit voltage. So the EMF is taken as 1, and here the equivalent reactance is J 0.04. The fault current IF is equal to 1 by J 0.04, which is equal to 25 per unit. Short circuit MVA is equal to per pre-fault voltage in per unit into fault current in per unit into base MVA, which is equal to 1 per unit into 25 into 25. So we get 625. So the fault current is the inverse of the reactance or the impedance. So it is 1 by 0.04, which is 25 per unit. So it is clearly seen that the fault current is very high. It is going to be 25 per unit. The voltage value itself we used to take it as 1 per unit. So the current fault current value is 25 per unit. So you can imagine what is the maximum current that takes place when the fault occurrence occurs in that system. Thank you.